All right, we're going to get started. It is the top of the hour. Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to be hearing from Mark Hendrickson about Beast Academy Playground, math, games, and crafts to foster curiosity and build problem-solving skills. Would everyone please introduce themselves in the chat window, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. I love seeing so many people from different places around the world, not just the United States, but China and, oh gosh, Romania. So feel free to type into the chat what you teach, where you teach, and what your Twitter handle is, if you have one. All right. Glad to see so many people here tonight. Before I introduce our speaker, I'd like to explain how these meetings work. These meetings are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The global math community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll be sure to catch your questions for the presenter to be addressed at the end of the presentation. Our speaker tonight is Mark Hendrickson. Mark is a senior math curriculum developer at Art of Problem Solving, where he developed Beast Academy Playground, a collection of free tabletop math games and activities for parents and educators. As a member of the elementary math team, he also writes for Beast Academy, an advanced comic-based math program for students ages 6 to 13. Before working at Art of Problem Solving, Mark taught middle and high school math for 10 years in Orange County, California. And I will now turn the floor over to Mark.
Thank you. Hi, everybody. This webinar format is a little foreign to me, so it's weird that I can't see you all waving back, but I'll just imagine it. So thank you very much for being here. I'll introduce myself and we'll dive in, but yeah, I just wanted to thank you all for taking time out of your day. I was a teacher for 10 years, and I know that I was often very exhausted at the end of the day and at the beginning, and sometimes in the middle, so I appreciate your time. Yeah, I am now a senior math curriculum developer at Art of Problem Solving. If you're familiar with the curriculum, people are sort of familiar with different aspects of Art of Problem Solving. I was familiar before I joined the company with the sort of middle through upper school math curriculum that they have, which was sort of for more advanced learners. And when I joined the company, I joined the elementary team. So the elementary curriculum at Art of Problem Solving is called Beast Academy. Like Lee said, it's oh, thanks. Like Lee said, it's comic book based. So the little beasts, figure out problems together and have little challenges together. And anyway, so I spend a lot of my days writing that kind of thing. I don't get to write the comics, but writing problems for that. But before that, I was a teacher for 10 years. I taught 6th through 12th grade math, everything from pre-algebra up to AP calculus. And I also had a after-school math club, I guess you could call it, for elementary students. And we spent a lot of time just trying to have fun doing some math after a full day of school with little ones. And that was an experience for me, coming from middle and upper school teaching, to get to play with kids and do math that way. So, the other experience I have with elementary age kids is my own kids, who are 5 and 8, and apologies in advance if you hear them clunking around during the webinar tonight. If you have any questions at any point, feel free to type them in the chat, but you can also reach me after at my email address is here. So let's dive in. My goals for you for this evening for us, I wanted to just show you Beast Academy Playground, introduce you to the website so that afterwards you can navigate it and find whatever you're looking for. I'm going to show you more tonight than we'll have time to really do. And so my hope is you'll be able to go back there and use it as you see fit. I also want us to think about why we should carve time out of our teaching time to play games and have fun in class. I mean, have fun playing games. Of course, lessons are fun with the right teacher. But when I was teaching, I had a comic strip up on my wall, and it was a math teacher walking into the room and saying, "We're way behind in the curriculum, everybody." And the subtitle was "The First Day of School." And so I always felt the pressures of moving through the curriculum as a teacher. It's hard to carve time out for this kind of thing, but I think we all know, and you're here tonight because you know that that's right. That playing games is not just fun for the students, it's fun for us. It's why we got into math, probably. We think it's fun and we like to play around with it without always having a really specific goal in mind. Having goals in mind as a teacher are really important, but it's also important to have time to play and see where that goes. And then my main goal for us tonight is I just want to show you as many different games and crafts and whatevers that I can, so that hopefully everyone here will leave the seminar with at least one thing that they've seen that they think, oh yeah, I'm going to take that and I'm going to do that with my students. There are more activities on Beast Academy Playground than I'll have time to share with you tonight. So I've put images on these slides. You can see one on this slide here of games and things that we won't even get to, but I'm hoping to sort of pique your interest in so you can check them out later. This one is from a game called Cookie Cutter. You'll have a chance to look at that later on your own if you want. Before we dive in, I think I wanted to start just by playing a game. It felt silly to have a webinar about games without actually playing something. These don't translate super well to online. I picked a couple that do. We'll play at least one of them, but maybe both. But I wonder if someone would like to volunteer to be my opponent in one of these games. If you'd like that, you can just let me know in the chat. So any volunteers to play Troll Hole with me? The rest of you can be spectators for this first game. All right, Lebo. Let me give you a link here. Thank you for volunteering. So you can follow this link. I'll share this link with everybody afterwards, but in the meantime, I'll share my screen so that we can all see the game that we are playing here. Okay. If you haven't used this website, it's called playingcards.io. If you find yourself doing some remote teaching, it's a really great way to have students playing games together. It's very flexible. This is a paper and pencil game that I've adapted to playing together online. You can have students play card games together where they're each able to see their own hand without others seeing it. And there's like a virtual table that they can put their cards down on and then everyone can see. So a pretty fun resource. Okay, so Lebo, I can see your cursor moving around, so I know we're both here. So to play this game, we start by drawing a 19-circle hexagon. And we're going to take turns on a piece of paper. We would take turns writing the numbers 1 through 9. Lebo and I are going to take turns dragging these markers onto the board in order. But because there are 18 numbers that we'll be writing, but this is a 19-circle hexagon, there will end up being one empty circle when we're done. And that circle will be the troll hole. The troll pops out of the hole and then eats all of the numbers that are immediately adjacent to the troll hole. And whoever has the highest remaining total wins. we can try playing this here. It's always a little easier to understand rules once you've played around. Lebo, would you like to go first? You can drag this red one anywhere onto the game board that you'd like. There you go. I think if you click and drag. Okay. And then I'll take my turn, so I'll write a 1 there. When you're playing a game for the first time, I ask, my colleagues and I, as we tested out these games, are you trying to employ a strategy the first time? Usually not. Usually you're just playing around and fiddling and seeing what happens. How does this game work? It could be this very first time we don't even totally understand how the end of the game is going to work and what the winning condition will be. Okay, let's see. I'm getting to some bigger numbers here, and I really don't want the troll to eat them. It's kind of an interesting board we've ended up with. Just thinking. Okay, I'll go here. Once everyone has written their numbers on the board, then the remaining hole is the troll hole. So there's our troll. And the troll is going to eat these numbers that are adjacent to the troll hole. So we'll remove these from the board. If you were playing on a piece of paper, you just cross them off. And now to see who wins, we need to add each of our remaining numbers and see who has the higher total. So let's see. I could do 2 plus 9 plus 7 plus 8. Or this is a great opportunity for younger kids to think about clever ways to be adding. So I could notice that I have a 9 and a 1. That's 10. 2 and 8 is 10. So I've got 20 there. 4 and 6 brings me to 30, 35. So I'm at 42. Oh, my favorite number. So I've got a total of 42. And Lebo, looks like you've got 10, 20, 31. So I won this round, which isn't really fair because I've played this game a lot of times, but thank you for being my my volunteer to play this one. Are there any questions about the game or any thoughts you have? I'm especially curious about, what math content you feel like might be involved in this game. Thank you. Yeah, what sort of content is involved in this game? If you were thinking, oh, I've got to work this game into a specific unit of study, what might your students be learning? Or if you feel a little freer to just work some games in for the sake of playing games and developing strategic thinking, what content is involved in here? So you can let me know in the chat. Get my slides back up. Spatial awareness, spatial reasoning. Yeah, both in the gameplay and also, this board came pre-populated because we played it online, but drawing a 19 circle hexagon is no freebie. Setting up the game board itself. adding numbers to 10, making tens, finding friendly pairs that add to 10. Any other ideas? Looking at that final board, did anyone notice a way that we could have determined who won without adding up all the remaining numbers? Strategic thinking? Yeah, I agree. And it's hard to employ a strategy when you're playing the first time, but you can imagine your students playing this first game, seeing how it works, and then immediately wanting to play that second game. Oh, now I think I have an idea for what I might do to try to win this next game. Right. So the removed items in this case, or when you play paper and pencil, you can see the screenshot here. The crossed off numbers are all you really need to look at. You can subtract them. So one of the things I like about all of these games and games in general is, usually there's a lot more going on than is on the surface. And the more you play them, the more you're sort of willing to dive into that, or our students will be. I think we've got time for another game. Can I get another volunteer? Or Lebo, do you want to do this one with me as well? Bumper cars? That's true. If we're not really concerned with the total, if we're only concerned with who has the higher total, we can eliminate the same numbers from both sides. I like that strategy. All right, Lebo, let me send you this other URL. Okay, so this next game is called Bumper Cars. I'm a big fan of playing games on paper whenever possible, so this isn't ideal as far as I'm concerned, but it's nice that it's an option. To play Bumper Cars, you start by drawing a road, any little squiggle of a road that you like, and then you draw any number of dots on the road. So I've drawn us an 8-dot road here. It's important to identify with the other player where the start and end of this road is. Let me just make sure everybody's... Lebo wants to win this time. I am terrible at this game. If I win, it is definitely lucky. And I wrote out the strategy for the for the game, so I should be better, but I'm not. Lebo, are you with me on this page? If you are, move your cursor. Just want to make sure we're both in this room. If you're with me, go ahead and maybe move one of the tokens just so I can see. Maybe I gave you the wrong URL. Do you see bumper cars and one blue and 3 red tokens? Okay. Let me just send you this again one more time.
Lebo says he's able to move them.
Oh, interesting. We're not seeing the same screen then. That's odd. Did you enter maybe as a spectator? Let me try refreshing my screen. Maybe it's on my end. Okay, so... Oh, there we are. Okay, cool. Nice. So that looks like that was my problem. Okay, so to play bumper cars, like I said, you draw a road, any number of dots. We have to agree which direction this one-way road is going. So I've set it up going from left to right. This is the, if we have a car on this dot and all the other cars are back here, this car up here is the frontmost car. And we're going to take turns. On a turn, we can pick any car we like and move it forward as many dots as we like. But these are bumper cars. They can't pass each other. So this dot, this token, for example, could only move up to here. That's as far forward as it could go, because past that, it would have to bump into that car. We can, on our turn, either move any of these cars forward as far as we want, or we can pick up the frontmost car. And when we do that, we'll move it down here just so we can keep track of which ones we picked up. Now, to win the game, you want to be the person to pick up the blue car. Okay? So a bad first move would be for me to do this. Because if I did, now the blue car is the frontmost car, and on his turn, Lebo could pick it up. So I'm not going to do that. Was it here? I don't remember. But I will go first this time, and I don't know. I'll move this car there. All right, Lebo, your turn. I like watching people think in the form of their mouse moving around the screen. That's an interesting window into an opponent's psyche. Let's see. Oh, goodness. I guess I'll move that one there. Okay, I'm intimidated by the amount of thought going into these moves. I feel like worried I'm going to miss something here. One fun thing about this game, I'll just say while we're playing, is, if you feel like you figure it out, you can. So the only move I can make that won't result in an automatic win for Lebo here, I could pick up this. That would be bad. The only other move I have the option to do is this. So I've been sort of forced into a corner. And now Lebo's going to be in the same situation as I was. There's nothing he can do that won't guarantee a win for me, except to move this car. And we'll see how this all plays out. I was going to say, once you've played a version with 8 dots and 4 cars, you can try a version with 10 dots and 5 cars. You can vary where they are in the initial setup of the board. Okay, I think things are going to turn out well for me. Through sheer luck, I will admit. So no cars can be moved forward. The only thing we can do is pick up this front car and drop it off in that. We'll just drop it off in the box down there. Okay. And now the front car is the blue car. On my turn, I am allowed to pick up the front car, so I'll pick it up. And because I picked up the blue car, I won this one. Okay. I feel bad I won both. That's not usually how these things go for me, but I will totally admit that it was luck in this case. Thank you, Lebo. Get these slides back up. So I'm curious about this second game. The first game seems inherently mathy. We're adding, if we're clever, we're maybe subtracting or doing something else. The second game, I could see playing this with a classroom full of students and being asked, why are we doing this game? Where's the math in this game? Yeah, if your colleague teaches game theory, they're going to love this. And they may very well recognize this. This is a John Conway game, thinly veiled to include bumper cars to make it a little bit more exciting. The The number of dots can vary, and the number of cars can vary, and where you set them on the board initially can vary. The only rule in setting them out, and this is explained on the website, is that you can't put the blue car in front as the starting position. I suppose you could, but then the game is over on turn 1. So as long as the blue car isn't in front, any starting position works. Kinetics, that's interesting. I don't know enough about that officially to know, but it does seem like it's mimicking some sort of natural process of particles moving around. I'm not a particularly competitive person. When it comes to games, I shy away from things like that often. And yet, I think when you're playing a paper and pencil game, especially with a classmate or a friend or something, just the stakes are low. You're as interested in just sort of investigating how the game works for the sake of understanding it as you are in winning, which isn't to say winning isn't a good motivator for students. I think it will be. Nancy, I'm going to be sharing the website right now, actually. So just wanted to sort of us to get our feet wet playing a couple of games. It would be fun in a geometry class to vary the game, maybe by working with some geometric shapes. Like you could start with, I don't know, some sort of hexagonal track or something. I mean, it's just a veneer of geometry because changing the shape of the board doesn't really change the game in any fundamental way, but might as well. So before I share the website with you and give you a little tour, and we'll look at definitely some more games, I just wanted to talk a little bit about the philosophy that went into designing these activities. So one of the main things that I think is important as a teacher, I imagine you think this too, is we know how well a class goes when we're able to sort of pique our students' curiosity early in a lesson, when we're able to like ask a motivating question, something that is accessible to everybody, whether they're really a great math student or not. They hear this question and it's just inherently a good question, and you wonder, what is the answer to that question? And then you actually get to spend your class time exploring answers to questions that you've genuinely wondered about at the start. So, finding time for our students to be curious, to wonder about things is so important. And we know that as teachers. Games are such a good way to do this because even if they're very explicitly mathy type games, they're still games. You still have some sort of strategy involved beyond just practicing basic skills. And as we saw with bumper cars, the second game, sometimes a mathy game, a game that is definitely involved, that is definitely very mathematical in the broader sense, doesn't seem mathematical in our students' maybe more narrow sense of what math can mean. Maybe there's no addition or multiplication or factors or whatever. But if we're thinking strategically when we're playing a game, we can recognize that as mathematical thinking, trying something and seeing if it works, analyzing why it did or why it didn't. Another thing that we sort of came back to over and over again as we were compiling and putting together these activities is we wanted to make sure that we had games that sort of would reinforce basic skills. Like in Troll Hole, we saw addition. It's good for practicing writing numbers, but at the same time, we didn't want anything to slip through the cracks that was more a lesson than fun. So the collection of things that I'll show you on the website are fun first. They had to be fun before they were a lesson in order to make the cut. Our students can sniff out when something is just a lesson that's been disguised as a game, and they can tell. And when something is genuinely interesting and engaging in its own right, and maybe there's some math involved, that's a lot more motivating for them. Another thing that sort of I thought about as I was writing up notes for all these games, which I'll show you, is the importance of sparking that curiosity, making your students wonder. And then as they express questions about how the game works or how to win, or how you could change the game, whether if I change the game in such a way, whether it would still be fun to play, or maybe that ruins what makes it fun. As these questions get articulated, it's really important to just not know the answer right along with your students. It's okay if you don't know the winning condition or the optimal strategy for bumper cars. It's still a fun game to play. The more you play it, the earlier you'll notice in the game who's going to win. The more intuition you'll have. And even if you as a teacher don't know all of the answers, it's good that your students are asking them. And it's good for us as teachers to model that, hey, when we don't know an answer, we like to investigate and just find out. Even if we're not sure we'll be able to figure it out, that we don't let that deter us. We like to investigate things and see what we can do, problem solve, basically. Another thing that's important as we're playing these games with our students is to notice things out loud for them. You know, they may be playing and noticing that they just made a bad move, or that their opponent just made a bad move, or that, you know, maybe there's some best first place to put your 1 in the troll hole board, or maybe there isn't. It really only matters towards the end of the game. As they notice these things, we can help them by noticing them along with them out loud. We can say, oh, I notice that you really like to put your 1s in corners of the hexagon. And then as we notice things, we can adapt the games. As I show you a lot of these games tonight, I'm going to ask in a lot of cases, you know, what adaptations could there be for this game? How could we play this with older students? How could we play this with younger students? I see Terry saying troll hole could be used from Y1 to Y8. Yeah, I mean, my hope for these games, there are a few that I think would feel a little too elementary for older students, but not many. I really think that the games are hopefully inherently interesting enough themselves that even if your students are already good at their addition and don't need to be practicing that, they might still just be motivated to play because the game itself is fun. The last thing I wanted to say on this slide is just, I know from being a teacher how hard it is to find time to play these games and have that kind of fun in a way that doesn't always necessarily relate to the lesson. And I personally, as a teacher, found it helpful to have sort of a rhythm. So one thing I would do is on test days or quiz days, you know, there's always that awkward bit of time at the end of class. What do you do with that time? That's a great time for games. Everybody's brain is fried anyway. Let's just relax and play some games or make a craft or do something that is low stakes and fun. I also really liked taking the last day before winter break is coming up, or spring break, or whatever breaks you got, to just have some fun. Schedule the exam or whatever you need to do for the day before that, so you've got some time to just have fun with your students and show them, model for them how math is not just, you know, a series of skills to be learned. It's like a way of thinking that we can employ even when we're just playing games and having fun together. All right, that's enough of me just talking about it. Let's take a look at the website. If you haven't already, the website is beastacademy.com/playground. I'm going to take us there now and share my screen to show you some things. I'm sure you'll be clicking around as well, but I don't want you to miss anything. So I encourage you to sort of stay with me for this part, and you can take a look at the website more on your own time. But let's see. So this is the Beast Academy Playground website. It's beastacademy.com/playground. And I'll sort of give you a little tour. You'll notice each of these blocks down here is one of our games. I'll be showing you several of these tonight. We just played Troll Hole. So to sort of get us started, since we've already played this game, I was going to show you some of the resources that we have for each game. So this isn't just a collection of the directions for each game. It's also a lot more. Let me start by sharing this video for you. You can click here to watch it on your own. For the sake of the webinar, I'm going to share it with you in a little bit of a different format so you can hear the cheesy music we put along with it. Each of these activities has a little short video. they're 2 or 3 minutes at most. Let's see. I think you have to click to hear the music here. And, if you find yourself watching these in a situation where you can't have audio on, that's fine, because all that they have is music. Everything you need to know is printed on the screen. Okay. We tried to pick music that was catchy, so apologies if you're humming some of these later. So that's the video. Each of the activities games has a video. You'll notice it has a brief description. It's got some guidelines for ages, but like you all have already observed, for many of these games, there's not really an upper age range. They're fun to play. If at the very top of the page, there's an option for you to toggle between whether you're looking at this as a parent or as a teacher. If we click on the teacher view here, it adds some fields that you'll be interested in if you're going to be using these in your classroom. For example, it adds just a list of standards that this game relates to. Some lists are longer than others. Bumper cars, it's a little harder to list specific content standards that relate to that game, but there are definitely standards for mathematical practice that relate to basically any strategic game. The rules are here in more depth than I shared them with you when we played together. And, written into the instructions is a hint to sort of look for pairs that add to 10. That makes your addition a little easier. And then every game and activity in Beast Academy Playground also has just some supplemental things. So every game and activity has variations. Maybe you want to play with 3 players. Well, the 19 circle hexagon still works for that, because each player can write 1 through 6, and you're still left with an extra hole for the troll hole. A kind of interesting question you could ask your students is, can you think of a circular pattern shape that would work for 4 players? How many circles would need to be in that figure so that the game worked out that everyone had the same number of turns writing numbers, and there was exactly 1 left over? That has to do with multiples. It has to do with factors. Even for more advanced students, it has to do with modular arithmetic, if you want to get into that. There's ways, to adapt these games up for older students. And one of the ways is to say, hey, I want to play this game with you all, but there are 4 of us. How are we going to do that? And let them sort of brainstorm how the game could be varied. For 2 players, basically, any board with an odd number of circles works. And here are some examples. So we give you those. We talk about how you can, scale this up for students who are working on 2-digit addition by starting at 10. And every player writes 10 through, and then it's kind of an interesting question, what number would they have to stop at? A lot of students will say 19 because they know that they wrote 1 through 9 for the single digit version. but 1 through 9 is 9 digits. 10 through 19 is actually 10. So if you're playing the 2-digit version of Troll Hole, each player would write the numbers 10 through 18, and there would be an extra hole left over for the Troll Hole. Another variation, if you're working on skip counting, is every player writes multiples of 2, 2 through 18, or multiples of 3. This is a variation for those students who feel like they've mastered the game Super Troll Hole. So instead of the troll just getting to eat the numbers that are immediately adjacent to it, it gets to cross off everything in its diagonals and its row, and then the remaining numbers are added. So every game has variations like these. There are more variations that you could think of. Also in every game or activity, we have classroom tips. These are only in the teacher view. So if you're up at the top and you're in parent view, you will not see the standards or the classroom tips. So just make sure you're in teacher view and you'll see all that. It gives you some ideas of things you might ask your classroom. Is there a good place for player 1 to start? That's an open question. I don't think there's a right answer that I'm aware of. I haven't analyzed the game that closely, but I like asking open questions. I like asking questions that I don't know the answer to too, and students respond well when we do that, when we ask questions and they can tell we're learning along with them. Let's see. If you are using the Beast Academy curriculum, we sort of indicate which sections of the curriculum these games align with. If you're not, you can probably tell just from the title, like when you might bring in these games. And lastly, every game and activity has learning notes. So these are just like, these are written towards parents, actually, non-math parents who might be playing these games with their young kids. But they're also definitely useful for educators, if anything else, just for ideas. So one thing you could do is you could think about what kinds of hexagons you can draw by tracing a quarter. What's the smallest hexagon you can draw by tracing a quarter, and how many circles does it have? This one has 19, so how many circles would the next largest hexagon have? And you can call these troll hole numbers. Does every troll hole number end up being odd? So is every hexagon you can draw with circles have an odd number of circles, or are there some that are even and so they wouldn't really work for the game? These are open questions that after you've played some games of Troll Hole, your students might be interested in investigating. Those Troll Hole numbers, those centered hexagonal numbers, I think is what they're called mathematically, are a kind of figurate number, just like the square numbers are a figurate number because they make squares, and the triangular numbers are. Centered hexagonal numbers. So I did remember that from some part of my brain. And so this could be an investigation you could dive into. Can we play a version of Troll Hole on a square grid? Which square numbers work and for which numbers of players? Does it really change the game? Like I noticed that in a sort of isometric layout like this triangle or like the hexagon, the circles are each touching 6 other circles if they're in the middle. But here, a circle in the middle is only touching 4. Or maybe you count the diagonals and a circle in the center is maybe touching 8 other circles. Does that really change gameplay? That would be an interesting question to investigate with your students. Since we also played bumper cars, let me show you that one. I go back to all activities. It can be sometimes kind of hard. I think we have 30 activities to find the one you're looking for. You can list them alphabetically, which I'll do because bumper car starts with a B. There it is. Let me show you the video for this game. Give me a moment. Oh, which activities are most popular? I'll share that after this video. Good question. All right, so let me show you briefly. Let me get back to the website here. Some of the resources that we have for bumper cars. Lee asked which activities are the most popular. Carronade, which I'll show you after this, is a pretty popular one. It's a symmetry game. Troll Hole is a popular game. We have a game called Fruit Flies, sort of like bumper cars. It's an abstract strategy game that if you're not careful, you might think there's no math involved in it. But of course, the strategic thinking that goes into determining how to win is a kind of mathematical thinking that we want our students to get to play, to get to see. Let's scroll down. The instructions are all here. We've got variations. These were mentioned in the video, just different numbers of dots and cars. Classroom tips. Does it matter how many dots and or cars there are? How do you know who will win before the game is over? Can you find a starting arrangement that guarantees player 1 will win? Can you find a starting arrangement that guarantees player 2 will win? And in the learning notes for this activity, we have sort of an analysis of actually how you can begin to analyze this game in the same way that someone, that a game theorist would. That's, not something that often makes its way into our classrooms, but it's definitely an appealing field of mathematics for students. I wanted to show you, next I wanted to show you Carronade. And before I do, let me just point out that we have some filters available. So you might decide that you really are looking for games that are going to practice some number sense. So you select number games. These will come up first. All of these involve numbers. There's Troll Hole, fun game we have called High Ground, the Blind Heist. These are all good games. This is just a simple memory game involving a custom deck that your students can make. This is definitely one that is probably not going to scale up to 8th graders. By the same token, I mean, being able to remember where things are, having that spatial reasoning isn't limited just to young kids. There are other filters you might apply. So you can filter by type, which I just did, by age. The age ranges are pretty loose. Maybe you're looking for something that somebody can play on their own. You could select one player. And this is going to bring up any arts and crafts we have, or any games that we have that there's a solitaire version of. Maybe you're at the very bottom, we have learning goals. These could be useful for teachers in particular. I'm really looking for something that involves multiples. My class is working on that right now. I've got a game here, Kangarooler, that will get them up and hopping around outside that involves multiples. And then there are other games that don't involve multiples, but actually, Trash Get Ball could. Anyway, I promised to show you Carronade. I'm getting off track here. Oh, we're getting low on time. I feel like I've only got time to really show you one more, and I want to choose carefully here. Maybe I'll let you just vote in the chat real quickly. This isn't what I had planned, but you could type in number game, strategy game, or craft. And I'll just pick one from one of those categories, and we can just take a look at it. An outdoor game, okay. Let's add that as a category. So outdoor game, craft, number game, or strategy game.
Yeah, so go ahead and type in the chat one of those options: number game, outdoor game, craft, or strategy.
And I've got to keep count of, let's see.
Let's see. Looks like it's either going to be craft or outdoor.
Let's do outdoor. And the good news is they're all online, so you can take a look at them after. Oh, craft, goodness. Okay, we'll do craft. Anybody want to be a tiebreaker between those two?
craft or outdoor game, whatever somebody puts in the chat next is what it'll be.
If you're not careful, I'm going to, because
I think outdoor games are kind of fun because as somebody that teaches older students, I don't always think about outdoor games.
Okay, let's take a look here. So we've got physical activities. This is we'll do Wrecking Ball. This is one that sort of scales up for older students. The way it's presented here in the video is indoor. Basically, the setup is that you have a pendulum that swings and knocks over these dominoes. But I played this with my kids outside where the pendulum is attached to a tree branch, and we've got little pins that we set up to knock over. So let's see. For the sake of time, I'm not going to show this video. I didn't prepare to show this one, but you can watch it. Suffice it to say that you set up 3 pins, and it's really important that they're numbered 1, 3, and 9. And then you set up some sort of pendulum and take turns knocking them over. Each player has a scorecard. There's my measuring spoon pendulum for inside. Each player has a scorecard with the numbers 1 through 13, and you take turns knocking over as many of these as you can. It really is quite fun on a large scale. So if you could get your hands on one of those giant exercise balls with a handle, I really wanted to try that, hanging from a basketball hoop or a tree branch or something. Sounds kind of fun. On your turn, you get 3 swings, and you knock over as many as you can. The cool thing about the numbers 1, 3, and 9 is by adding or subtracting those 3 numbers, you can make every number between 1 and 13. So if you knocked over 9, 3, and 1, you could do 9 minus 3 plus 1 equals 7, 9 plus 3 plus 1 equals 13, 9 plus 3 minus 1 equals, I lost track of this and I can't read that, 11. No, 9, yeah, 11. And 9 minus 3 minus 1 equals 5. So there's only one way to make each of these numbers. You can only make 5 by doing 9 minus 1 minus 3. And so as you play the game, you end up with only a few numbers left on your scorecard, and you can start to figure out, wait, if I need to get that 6, how am I going to get a 6? Oh, 9 minus 3. So I got to get the 9 and the 3. Let me aim for those first. The fact that these numbers are powers of 3 is something that older kids might be interested in. Wait, so you're telling me that if I add or subtract the first 3 powers of 3, I can make any number from 1 through 13? What if I bring in the next power of 3? What if I bring in 27? What numbers can I get to? And are there any on the list that I won't be able to get to by including 27 as well? There's lots of ways to vary this game. You could bowl, you could shoot hoops, you could make it a little easier and just practice addition by using the numbers 1, 2, and 4, the powers of 2, rather than the powers of 3. I feel like I kind of flew through that one, but I wanted to make sure and get through it. Are there any questions or just general things that, Lee, you've been keeping an eye on the chat for me, before we go, that people want to ask?
I think most of the questions were answered as you went along. Great. I feel like a lot of people want to go in and explore these themselves.
I would never do this with students. Here's a URL. Now don't go there while I give you a little tour, because you're going to go check it out, and that's fine. I really hope that you guys can find something that you want to do with your students. I'm not on Twitter. I left Twitter, and a community like this makes me regret that choice. But I will share my email address with you one more time, and I would love to hear from you if you use these in your classroom. There are so many that I really love. Oh my goodness, there I'm back on slide 1. There we go. So please do reach out to me. If you have ideas for future activities, we are planning on adding them periodically. I didn't get a chance to show you any of the crafts, but check out the arts and crafts category. We have a sort of cryptically named category called curiosities that has a couple magic tricks and optical illusion that I think kids really love that stuff because they can show it off to their friends. So thank you all.
Yeah, thank you. I think it's really cool how you can scale a lot of those games up. And
Mhm.
I think older kids even are like, why does that work? Like,
Yeah.
okay, it works, but why? Like they naturally want to know why when they're playing games like this. So
Yeah.
thank
Why
you.
would the powers of three have that property? I mean,
Yeah.
it's
Well,
magical.
I actually, in my math for elementary educators, we actually work with other bases
Oh
in
yeah.
that class. And so, the fact that 13 is 3 squared plus 3 to the first plus 3 to the
Mhm.
0 is why that works.
Exactly right.
So,
Yeah, and older kids could really get into this in a lesson on other bases.
yeah. Yeah, definitely cool. Thank you so much for sharing tonight. So we do not have a presentation scheduled again in December. Our next presentation is scheduled for January 11th. And that night we'll be hearing from Chrissy Allison. Chrissy's topic is building a bridge to grade level math in middle school and high school. Because as a lot of us know, if you're working with high school or middle school students and they have um, some prerequisite skills or gaps in their understanding, it makes it really challenging for them to work at the more abstract level that they often come across once they get into algebra and beyond. So join us on January 11th for building a bridge to grade level math in middle school and high school with Chrissy Allison. And thank you once again, Mark, for presenting tonight.
Thank you. Thanks, everybody.